Foundations of Amateur Radio. A little while ago, I discussed a lovely article by programmer, artist and game designer Blinry called 50 Things You Can Do with a Software-Defined Radio. This week it occurred to me that I could use their article as a framework to further explore my Bald Yak project. If you're unfamiliar, the Bald Yak project aims to create a modular, bidirectional and distributed signal processing and control system that leverages GNU Radio. For that to happen, I need a solid understanding of GNU Radio and its ecosystem. While I've been playing with it off and on for a decade or so, I have yet to build anything substantial for the simple reason that there was a puzzle piece missing. Last week, I discovered it. By accident. One of the fundamental things I'm attempting to achieve is the creation of a system that doesn't care which radio device you're using. In case you're wondering, I'm doing this because there is a proliferation of device-specific software that cannot keep up with the influx of new hardware, doesn't consider the growing use of network-connected radios forced by the increased RF noise levels in many communities across the world, not to mention connecting increasingly expensive computing hardware to lightning rods. If everything goes to plan, it should be possible to use the project with any radio device. This is easier said than done. In GNU Radio, this complex issue is addressed by having different blocks that represent different devices. You'll find receiver-specific source blocks and equivalent sync blocks representing transmitters. While that's all fine and usable, it means that if I were to publish, say, an FM receiver flow graph, essentially a collection of blocks representing software that implements an FM receiver, I have to decide how I want to deal with the specific device. Do I select an RTL SDR dongle as the device in my flow graph and let you figure out how to make it work on the Hack RF or the Pluto SDR sitting in your shack? Or do I make it completely hardware agnostic, requiring you to wire it all together for your specific situation? Neither is desirable or simple. Added to this is the problem that trying to make this work using a traditional analog radio would cause more issues, since there isn't a Yaesu FT857D block, nor is there one for an ICOM IC7400, let alone something from last century. Someone with some GNU radio experience might point out that there are source and sync blocks for an audio device, which would allow you to plug one of those radios into a sound card and access the receiver or transmitter that way. While that would work, it requires that the radio is physically connected to a computer that's running GNU Radio. It would also give you all manner of headaches attempting to change frequency in the same way as you could using an RTL SDR dongle. There are several ways to get remote radio control working across a network. For example, using Rig Control D and HamLib, we can change frequency on over 300 analog radios. But even if you do, you'll discover that getting the audio across the network creates a whole range of new issues. Not to mention that GNU Radio doesn't talk to HamLib-compatible radios. This is why many remote radio solutions are implemented as remote desktop sessions to a computer that is physically connected to the radio. While attempting to solve a completely unrelated challenge last week, I came across SOAPy SDR, described as a vendor and platform-neutral SDR support library. Essentially, it's a project that allows an application to interact with different devices, without needing to support individual radios. This allows an application developer to write their software to support SOAPy SDR, and from then on benefit from its ability to talk to lots of radios in a variety of different ways. For example, one of the inbuilt features is called SOAPy Remote, which allows you to connect to a SOAPy SDR radio and interact with it across a network. Specifically, you can send and receive as well as control the radio, essentially bundling together both the audio and control signals. SOAPy SDR also includes a tool called SOAPy Audio, While documentation is sparse, it appears to support hamlib, which means that you can, at least theoretically, connect a low-powered computer like, for example, a $5 Raspberry Pi Zero to your analog radio and access and control it across the network. Best part? It's supported by GNU Radio and many other applications. I've started creating a repository with the 50 things you can do with a software-defined radio, one directory per thing, that will contain the bits needed to run inside GNU Radio and across the network to any SOAPy SDR-compatible hardware. Now, before you get as excited as I am, there's a few hurdles. I'm not yet sure of the status of SOAPy audio, but it looks promising. I have the bits sitting on my computer and I'm working through them. For example, I'm not sure if the current implementation supports transmit. I also have anecdotal evidence that hamlib support is incomplete, but I don't yet know to what extent. I anticipate some coding in my future. I suspect it will be the equivalent of building a new SOAPy SDR module, but time will tell. I can tell you that I'm running an RTL SDR dongle connected to a low-power computer, and I can connect to it across the network with GNU Radio on my workstation and run a proof-of-concept FM receiver flow graph. There's no reason for either computer to be in the same room, let alone the same country. You'll find the project on my VK6FLAB GitHub page. I plan to work my way through the 50 items and discover what I don't know about GNU Radio. Feel free to play along. I'm Onno, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.